This is the easiest part of solving system of equations, the elimination method. The only other method that could possibly beat this is if you have a graphing calculator that all you have to do is just type in your equations and it'll do the rest. But you're simply just taking both equations and then you're trying to eliminate a variable by adding just straight down. And this one that is given, you can see that the coefficients are already opposites of each other, 2 and then negative 2. This will get rid of the y's, leaving just the x's. And then you can just add down on the other side of the equal sign, figure out what your x is. So, whenever you add down, you get 0, you get 2x plus 0 is equal to 12. 2x is equal to 12, and divide by 2 by both sides to get x equaling 6. And that is how you simply do elimination. This one, of course, is the easiest one. Sadly, you're not going to be getting problems like this because this is just way too easy. You, of course, have to finish this up. You plug your 6 into your original equation. So you would have 6 plus 2y is equal to 8. Subtract from both sides your 6's. And 2y is equal to 2. Y is equal to 1. Easy as 1, 2, 3. Now you have your new coordinates. Once again, only necessary if you're asked to graph. On to another example problem. This one is going to be in the case that they're not nice to you and they decide to give you a problem, then it's going to have mismatched coefficients. So you're actually going to have to do a little trick to actually get them to match, and somehow this works out. Your next equation is 5a minus 2b is equal to 3. 2a minus b is equal to 0. You can see the problem in this equation. You have a negative 2b, a negative b. These coefficients will not eliminate each other. They will not cancel each other out. Neither will the 5a or the 2a. So now you have to ask yourself a question. Which one's going to be easiest to multiply across the top or the bottom? And which ones would you have the coefficients match, but one be negative and one be positive? I would suggest that you go with the bottom of equation and then go with the negative b, because it would be way easier just to multiply across negative 2 so you can get a positive 2b. Alright. If this gets confusing, it's understandable. All of this is a lot to take in, but after you work out a few practice problems, it kind of just comes to you. You're going to multiply negative 2 across. So now you're going to have negative 4a plus 2b is equal to 0. Alright, this is your new equation. The reasoning for this equation is now you can just completely ignore the original for now. Alright, now that you have this, you're going to take, once again, you're going to add your 5a to your negative 4a. This is going to just give you an a plus, well, negative 2 plus 2 cancels it out, making b a 0 coefficient, eliminating b. So now you have a plus 0 equals. Now this is very important that you remember this for future equations. You have to take and add the other side of the equal sign. So in this case it doesn't really matter because there's a 0 on this side. But in future problems, if you forget to do this, you're going to have it completely wrong. So 3 plus 0, of course, 3. A equals 3. Now you're going to take, and much like the substitution method, you're just going to input your newfound information to one of the original equations. So you're going to take in 2a minus b is equal to 0. Like I've said before, you want to take the easiest one. So you take 3, so 2, 3 minus b is equal to 0. 6, negative 6, negative b, and then your answer should be 6. Your final answer is, for your coordinates, are 3 and 6. Stay tuned for part 3 so I can show you how to do it on a graphing calculator. This one is an amazing method to do, but only if you have the money to afford a graphing calculator.